Okay, before we talk about why tolerance develops, let's just do a brief recap. Remember, we've talked about the definition of tolerance, okay? Situation where the current dose of a drug no longer produces the desired effect. So, in other words, more drug is needed to produce the desired effect. We talked about some types of tolerance and we talked about how tolerance develops, either through physiological or biological mechanisms like metabolic tolerance, increased enzymes that break down the drug faster, or through learned or behavioral mechanisms, okay, habituation and conditioning. Now let's talk about why tolerance develops, okay? The most important thing to understand here, which I think is a big misconception that people have about tolerance, okay? Tolerance doesn't develop just because you take something over and over again. That's not why tolerance develops. Tolerance develops because what you took creates a disturbance, what we call a functional disturbance, that's of significance to the organism. Okay? So again, tolerance doesn't develop simply because you take something over and over again. Tolerance develops because the drug causes a functional disturbance that's of significance to the organism. Okay? So to talk about functional disturbances, we need to back up for just a second and talk about something called homeostasis, okay, or homeostatic mechanisms. Okay, so various processes in our bodies have set points, okay, or boundaries within which they function. So for example, if we think about our bodies and we think about body temperature, okay, we know that once you go above a certain temperature, then mechanisms kick in, you know, to try to get that body temperature under control, sweating, things like that. And remember, usually the only thing that causes that body temperature to get out of our ordinary range is if we have some type of infection or illness, okay, something that disturbs, causes a functional disturbance, right? Or if we're placed, say, in a very, very cold environment, if we're stuck outside and it's minus, 10 degrees, okay, the temperature could drop, or it rises, like I said, if it's fighting off some type of illness or infection. Those are functional disturbances. Similar thing when we talk about drugs. Tolerance does not, you see, I'm saying this again because I want it really to set in. Tolerance does not develop just because you take something over and over again. Tolerance develops because the drug causes a significant disturbance that's of significance to the organism. And it's only going to develop if what you took causes a functional disturbance. If you take a drug and it doesn't cause any change, then your body has nothing that it needs to adjust to. So let me give you an example. So you can think about a thermostat in a room as a homeostatic mechanism. So if I have this thermostat in a room set for 70 degrees, okay? So let's say that it's a Memphis, let's not assume anything about outside. So let's just say that I have the thermostat for that room set at 70 degrees. If I open up a window and the temperature outside is about the same as the temperature inside of the room, then the air coming into the room isn't going to significantly change the temperature inside of the room, okay? So the HVAC, or that air conditioning system, that system that's going to maintain the temperature in the room, doesn't have anything to respond to, okay? But if I opened up that window and it's 110 degrees outside and all that warm air comes into the room, then the systems, the fan, the condensers are going to kick in to try to get that temperature back down to 70. Okay, so you see what I mean? So in the same sense, tolerance only ever develops, if the drug causes a significant functional disturbance. Okay, so what you take has to cause a disturbance that the organism needs to respond to. Okay, again, tolerance does not develop just because you take something over and over again, but it develops only when what was taken causes a functional disturbance. Okay? And so when we talk about tolerance developing, you know, the body is trying to get back to that set point. Okay, that set point of functioning without the drug in the system, right? Just like that thermostat, just like the system that controls the temperature in the room is trying to get that room temperature back to 70. If you take a drug that causes a functional disturbance, then your body's going to try to get back to where it was in the absence of the drug, okay? So then your body's going to get better and better at counteracting the effects of the drug, okay? It's going to produce more enzymes, break down the drug, okay? So what we're going to see is that more often than not, what happens once an individual continues taking a drug, okay, and the body gets better at counteracting the effects so that more drug is needed to produce the desired effect, that what happens is that now that the individual is abusing a drug, you've got a new set point for functioning, okay? So it's kind of like, you know, when it's really, really hot in the summers in Memphis, and you've got that AC set at 70, okay? But you will hear a lot of the air conditioning companies telling you that your AC unit can only cool your house to about 20 degrees lower than what it is outside. So if it's 110 outside, realistically, we may not get back down to 70. That temperature may be 80. So given that extreme temperature outside, the constant temperature inside now is about 80, you know, which would be miserable, but that's what it is. And so if a person continues taking a drug and the body gets better and better at, you know, metabolizing, getting rid of that drug quickly, okay, then a new set point is going to be developed. Okay, so let's talk about how quickly tolerance develops. Okay, so the rate at which tolerance develops is going to depend on two things. The first thing is going to be the dose. Okay, how much drug you took. Why do you think that's important? Well, I'm glad you asked. That's going to be important because the amount of drug that you take has to be enough to cause the functional disturbance. So if you take a dose of drug that isn't going to cause a functional disturbance, then your body has nothing that it needs to respond to. So dose is important. How much you took, the dose. The dose has to be enough to cause that functional disturbance. The second thing that determines the rate at which tolerance develops is the time between administrations. How often do you take the drug? Okay? Now, one of the things that you're going to see over the course of the semester is that the drugs that pack a punch, i.e. the ones that cause that functional disturbance, okay, and the drugs that have short-lasting effects are going to be the ones that are abused more often, okay? See where we're going? So if the effects don't last long, then you take the drug sooner. Okay, the more times you take the drug, your body is going to get better and better at, you know, compensating for the effects of the drug. More enzymes are going to be produced to break down the drug. Okay, and as that happens, the person is going to continue increasing the dose, you know, until they're needing more and more and more to produce the desired effect. So hopefully you see how those two things fit hand in hand. The dose, because the amount of drug you take has to be enough to cause the functional disturbance, okay? And then the time between doses. The more often you take a drug, okay, generally those with short-lasting effects, then the more often your body has to respond to that functional disturbance. Okay, so let's talk about compensatory responses, okay? What are they? You may notice that I mentioned that word on the previous slide. Compensatory responses are the responses that your body makes in an effort to counteract the effects of the drug. They're trying to compensate for the effects of the drug. So again, compensatory responses are the responses that your body makes to try to counteract or compensate for the effects of the drug. So it's just about what it sounds like. Compensatory responses. Your body is making responses to counteract or compensate for the effects that are produced by the drug. How do those responses affect the body's reaction to the drug later on? So how do these compensatory responses affect the body's reaction to the drug later on? Okay, so your body makes these responses in an attempt to counteract or compensate for the effects of the drug so that when the drug is taken again, the body is less susceptible to the effects of the drug, i.e. the effects are diminished or reduced. See how that works? Okay, so the body is less susceptible, okay, when the drug is taken later on. What is the end result? If you're following me, you'll notice that this is just another way that we've done a step by step in the development of tolerance. The end result is tolerance, okay? So let's recap briefly. Compensatory responses are the responses that your body makes to try to counteract or compensate for the effects of the drug, so that when the drug is taken again later on, the body is less susceptible to the effects of the drug. The end result is tolerance. Okay? And so this is just an add-on that's talked about in your chapter when it says, when do these responses become conditioned? Okay? Remember, when we talk about conditioning, we're talking about learned associations between a stimulus and some reactions or responses. Okay? So in this case, compensatory responses become conditioned if there's some stimulus present whenever these compensatory responses are occurring. Okay? Do you see where we're going? So if the bell is present when the food is being presented, then an association is learned between those two things. Okay? So if these compensatory responses, if tolerance is developing in the presence of some stimuli, then that tolerance will become associated with those stimuli. We call this conditioned tolerance. Now, that's oftentimes a concept that's hard to wrap your mind around, okay? Because what we see with addicts most often, or oftentimes, is something called conditioned tolerance. That the tolerance that the addict develops, or that the drug user develops, can become conditioned to a particular environment, okay? And the interesting thing is that when the tolerance that's developed becomes conditioned to a particular environment, if that individual takes the same amount of drug in a new or different location, they can have a sudden loss of tolerance and overdose. Okay? That is how powerful the effects of conditioning are. If you'll read through your textbook, you'll see an example of rats that were in a laboratory study. They were given injections of heroin in a particular room in the laboratory day after day after day. And then for part of the experiment, they were moved to a different part of the laboratory. Okay, and just that slight change in environment, when they were given the same dose of heroin, half of the rats dropped dead. That is the power of conditioning. Okay, so if tolerance becomes conditioned to a particular location, if the drug user takes the drug in a new or a different location, you could have a sudden loss of tolerance, which means that you're going to get the opposite effects. Rather than getting diminished or reduced effects, you're going to get increased effects, which could result in an overdose, could result in death. Okay, now let's introduce a new term, dependence. What is dependence? This is a condition where reducing the dose of a drug or discontinuation of the drug leads to the appearance of withdrawal symptoms. Okay, so if an individual stops taking a drug or reduces the dose and withdrawal symptoms present themselves, then they're said to be dependent. Okay, so if you stop taking a drug or reduce the dose, and withdrawal symptoms become apparent, the individual is said to be dependent. Okay, so we're going to talk about two types of dependence: physical dependence, okay, or physiological dependence. Now, the definition of dependence is the same. Stop taking the drug, reduce the dose, you get the presence of withdrawal symptoms. When we talk about physical or physiological dependence, you stop taking the drug, reduce the dose, you get the appearance of physical withdrawal symptoms. Okay? When we say physical or physiological withdrawal symptoms, these are withdrawal symptoms that we say are easily verified by laboratory, in a laboratory type setting. So if you can show increased heart rate, increased blood pressure, if you, could measure brainwave activity, EEG, and so forth, things that we can confirm that are scientifically verifiable. Okay, so with physiological dependence, individual stops taking the drug or reduces the dose, you get the appearance of or presence of physical withdrawal symptoms. Okay, with psychological dependence, we're saying if an individual stops taking a drug or reduces the dose, you get the presence of psychological withdrawal symptoms. Okay, now what's special about psychological withdrawal symptoms? These are withdrawal symptoms that are more subjective in nature. I'm angry, I'm agitated, I'm anxious. Okay, so we're not saying that these things do not exist. We're just saying they're harder to either prove or disprove. Okay, I could be perfectly fine and tell you that I'm anxious, and it'd be very hard for you to prove that I am or am not anxious. Okay, because I could, if I know how to, and I'm not saying that people, trick, but if I know how, okay, an anxious person reacts, I could be perfectly normal and behave in that manner. Okay, so I can fill out questionnaires and indicate that I'm anxious, indicate that I'm irritated, agitated, etc. But those things are still subjective. It's very difficult for you to either prove or disprove. Okay, so remember, we're not saying that these things don't exist or that they're not real. Psychological withdrawal symptoms are very real. We're just saying that they're harder to prove or disprove. Okay, so let's talk a little bit about withdrawal symptoms. Okay, what are they? These are the symptoms that are apparent when an individual stops taking a drug or reduces the dose. Okay, when can they occur? They can occur anytime after the last administration. Okay, so depending on the drug, sometimes it's minutes, sometimes it's hours, sometimes it's days, sometimes it's weeks. So it all depends. So they can occur at any time point after the last administration. Now, this next question is very, very important. What are they in response to? What are withdrawal symptoms in response to? Okay, now, most people, the first thing they're going to say, you have withdrawal symptoms because of the absence of the drug. Well, think about this. Our bodies are always trying to maintain homeostatic set points. We're always trying to maintain these set points for functionings. So, withdrawal symptoms aren't simply in response to the absence of the drug. The withdrawal symptoms are in response to the functional disturbance that's caused by the absence of a drug. Okay? Everybody get that? The withdrawal symptoms are in response to the functional disturbance that's caused by the absence of the drug. Okay? And another way to say that, the withdrawal symptoms are in response to the body trying to establish or reestablish a set point. The body's attempt to maintain some homeostasis. Okay? So I hope that what you see here is that when we talk about the development of tolerance, and even when we talk about withdrawal symptoms, both of those things are ultimately about functional disturbances and about the body trying to maintain a set point. Okay, so when you take a drug, if that drug causes a functional disturbance, the body responds to it. It gets better and better at reacting. Okay, so that the body is less susceptible. And so you get the development of tolerance. And so along with that development of tolerance, you've got a new set point. Now, all of a sudden, you stop taking the drug or reduce the dose. That may cause another functional disturbance. And so the body is going to try to reestablish homeostasis. Okay? And so I point out the fact that the withdrawal symptoms are not simply in response to the absence of the drug, because if you look at this little orange wedge here that's at the bottom of the slide, some withdrawal symptoms are not detectable. So that's a case where the body has nothing to respond to. Okay, so there's some withdrawal symptoms, that are not even noticeable. A person sometimes for certain drugs doesn't even realize that they're going through withdrawal, okay, because they're undetectable. And then you have some withdrawal symptoms that are so severe that they can result in death. Okay, But the important thing there is simply to remember that whether we're talking about the development of tolerance or whether we're talking about the appearance of withdrawal symptoms, it's all about functional disturbances and trying to maintain homeostasis or set points. Okay, so let's just talk about conditioned withdrawal responses. This should be pretty straightforward because then again, remember, conditioning, we're just talking about learned associations. Okay, so when do they occur? You're going to get conditioned withdrawal responses if a stimulus is present when the withdrawal symptoms are occurring. Okay, so if I'm going through withdrawal and I'm in a bright red room, then maybe the color red becomes associated with the unpleasant withdrawal symptoms that I'm going through. Okay, so that's a probably oversimplistic example, but we're just saying that conditioning only happens if there's some stimulus present when there are these withdrawal responses, withdrawal symptoms happening. Okay, so when do they disappear? Okay, so withdrawal symptoms, okay, are going to disappear when the individual can be in the presence of the stimuli, okay, or the stimulus, but not partake of the drug. So some people's first reaction is that, well, you get rid of the withdrawal symptoms by taking the drug again. Okay, so if an individual is abusing drugs, our goal is to get them sober, to get them off of drugs. So we don't really want them to take the drug again to get rid of withdrawal. So if the individual can be in the presence of the stimulus, but not partake, then those conditioned withdrawal responses will disappear. Okay, so sometimes we refer to things, this is similar to what we call, I'm losing my vocabulary, this is extinction. Okay, so if I can be around something and unlearn, if I can unlearn the association. Okay, all right, so our last term for this chapter is sensitization. Okay, when we talk about sensitization, we're talking about increased responses to a drug after repeated doses. Okay, so if you notice, because I said it's increased responses to a drug after repeated doses, this is also known as reverse tolerance because it's the opposite of tolerance. Okay, remember, with tolerance, we're talking about the same dose of the drug no longer produces the desired effect, or it has this diminished effect. So if we said repeated doses of a drug associated with diminished effects. With sensitization, we're talking about increased effects associated with repeated administration of a drug. So sensitization is also known as reverse tolerance. Now, let me say this before you go on. One of the things regarding drugs of abuse is that when we talk about sensitization and increased effects associated with repeated administration of a drug, okay, sensitization generally does not occur with respect to the pleasant effects of the drug. It's usually, the fact that sensitization develops to unpleasant effects associated with the drug. So we'll talk about this a bit more when we get to the chapter on psychomotor stimulants, including cocaine. So one of the things that increases that we show sensitization with cocaine is to psychotic episodes. A person has increased risk for what we call schizopsychosis. There's also increases in what we call punding, or repetitive behaviors. So these are not pleasant effects associated with the drug where we generally see sensitization. Okay, in animal studies, we might often see sensitization increase locomotor activity or things like that. But we'll address those. This term will come up again in the psychomotor stimulant chapter. Okay, so let's just finally introduce the term cross-sensitization. Okay, now remember that sensitization is also known as reverse tolerance. So this definition, cross-sensitization, is just the opposite of cross-tolerance. Okay, so in this case, we're saying that if sensitization develops to the effects of one drug, okay, then sensitization will also likely develop to the same effects of a closely related drug. Sound familiar? It's just the opposite of cross-tolerance. Again, cross-sensitization. If sensitization develops to the effects of one drug, it's likely that sensitization will also develop to the same effect of a closely related drug.